So, hi everyone, and welcome. As you already said, we came here today from Istanbul, Turkey, and we're from Hisar School. So, at our school, you could say that we're pretty invested in computer science. We do a lot of work in the area. We participate in robotics competitions, and we do projects like autonomous robots or mobile apps. But I think what really makes computer science at our school interesting is that almost all of our learning is based on peer learning. So that applies whether we're talking about an AP computer science course or actually a club that meets during after school hours.
So what is peer learning for us? For us, peer learning is us students learning from and with other students, whether this may be through working on some projects or just teaching somebody a new skill or working on a tough problem set. Thanks to this peer learning system, we have been in the unique position to experience computer science both as a student and as an educator at such a young age. So now let's get a little bit more specific about a few times where we've seen peer learning be really effective for us.
Alright, so story time. Peer learning is actually how I started learning Python in the first place. So I was in 9th grade and I really wanted to learn how to code. So I went and talked to my computer science teacher about it. There. And he introduced me to Radfi, who is another student around my age who had just started out in Python as well. So Radfi and I started working together, and he kind of taught me what he had learned so far about Python. And I was actually surprised at how easily I understood him. And I think a big part of this was that because our ages were so similar, we kind of had a similar way of thinking and communicating, which means that I could easily relate to his explanations and what he was saying. Also, with Radfi, I was never really embarrassed or ashamed to ask questions, even though I'm mostly a really shy person, because I knew that he wouldn't judge me or really shame me in any way because he had been where I was just a few weeks ago. So I was very comfortable with him, and it was really a lot more easy for me to not be intimidated by computer science since I had a friend there to guide me through it and kind of teach me. And actually, Radfi and I are still really close friends after this, even though it's been like 3 years since we met. And we met up the other day, and we were reminiscing about how we first met and how we were working on Python. And he mentioned that actually watching me improve as he taught me and watching me solve harder and harder questions and kind of making cooler things really motivated him as well in his own learning journey. So not only did it make it easier for me to understand and appreciate Python, it also really made it easier for him to keep his momentum and continue learning.
Another situation where peer learning enhanced our learning experience was during FRC, First Robotics Competition. This is a competition where teams build a large-scale robot in order to compete in challenges during a 6-week period. Since this was our first time building a large-scale robot, something bigger than a shoebox size, we had a lot to learn. And we learned most of our knowledge through peer learning. Since we didn't have any person like Ralphie that went through this way, that had prior experience with a competition like this, most of our learning comes from research and exchanging information with our peers. During this stage, our teachers provided us with resources and an environment where we can safely make mistakes and learn from them. Because of this, the rewards were very wonderful. Since we could say that we did the robot, like small things, like trivial things such as making the robot move for the first time or completing a small task in a big challenge was incredibly nice, and we were really happy about it. And we don't think that it would have give us the same excitement if it was an environment where teachers told us what to do, how to do, and how to implement it. One of the most beneficial things about peer learning is it makes you grow closer with your friends and develop group project skills. And it sets you up for a lifetime self-directed learning, which is gorgeous because we're in a topic of computer science and there's always something new to learn.
Okay. So going back to the classrooms and our AP CSA class to be more specific. So just to give a quick overview, APCSA is the advanced placement course for introduction to computer science for Java. And we have the APCSA courses in our school as elective lessons. And in these APCSA courses, we use a problem-based approach. So in the classes every now and then, students get a problem at the beginning of the lesson, and they have some time to work on the problem. And as you know, in programming, like a problem can have thousands of different solutions. And so every student approaches the problem differently, and this leads to wildly different solutions. So after everyone gets a stab at the question, students then reflect with their classmates and talk about their answers. And this creates a really good environment for peer learning and reviewing their mistakes and learning from other students' approaches. And another really crucial benefit of this problem-based approach is critical thinking. So because we don't have a teacher going up to the board and just giving one answer and the students memorizing that, we have the students actually thinking about the problem and trying to find some solutions. And students then learn about different approaches to the problem by reflecting with their classmates. And I think that this improves our critical thinking skills and will help us throughout our lifetime.
All right, so we've talked about a few examples now, and definitely over the years with peer learning, we've gained a lot of skills. So what we wanted to do next was kind of share these skills with other people and also spread the peer learning culture more around Turkey. Especially, this isn't really a thing in Turkey, it's more of the teacher goes up to the board and the students just write everything down. So we really wanted to share this approach with other people. And with this idea began the Hisar Coding Summit, which is an event that we host at our school where us students host workshops for other students in various topics in computer science. So these could range from 3D design to Python to Arduino. And this year we actually had over 250 students from all around Turkey attend our summit and who take part in our workshops. So that was really great. And actually, basically what it's all about is summarized in our motto, which is from students for students. So really that tells us a lot about the peer learning approach that we take towards CS education and that we try to apply with this event as well. So what we tried to do with this event was kind of take the peer learning techniques that we'd experienced in school, and we'll talk more about those in a minute, and kind of apply them to our own workshops that we were teaching. Except in this case, we weren't really the students that were learning, but we were kind of the teachers guiding the process. And doing this actually also helped us appreciate how hard teachers' jobs are. So props to all of you teachers out there. And overall, after the event, we really had a lot of students and participants reaching out to us and telling us how useful it had been and how much they had learned. So for us, this was really proof that the peer learning approach actually worked.
Although we believe peer learning is awesome, there are some challenges that comes with it. Since we discussed about what are the benefits, now we're going to have a little discussion about what are the challenges we experience throughout the way. For example, during FRC, one of the biggest challenges we faced was indecision. Since everybody had their own way of approaching to the challenge, and our teachers never gave us a direct instructions on which is the best way to approach the challenge, we tried things out, and we had a bunch of robot designs and prototypes that we didn't end up using. This made us waste a lot of time and resources on something that never worked. And with this comes a problem called time management. And it didn't help that we were teenagers and we left most of this stuff to the last night. And because of this, we basically experienced a bunch of last-minute situations, which was very stressful, even though we learned a lot from it. Sometimes it wasn't the best choices.
We've talked about some of the instances where peer learning helped us, and We hope that we've convinced you in some way that peer learning is actually effective. But now we'd like to talk a little about how you can implement peer learning in your classes. So, like, are there any educators or teachers among you? Yeah. Nice. So, I think the number one way that you can implement peer learning in classes are through independent group projects. So, in group projects, as we said, people have really interesting ideas, and there is an exchange of ideas between students. And this really fuels discussions and ideas. So also, what group projects does is it motivates students to persuade computer science. Because students do something on their own and come to that point, they're more proud of they're prouder of their achievements. And also another great thing about group projects is students get to create cool stuff, which makes them realize that the skills that they're learning in the classroom aren't just useless skills and can actually be implemented in the classroom. And they can be used to create really cool projects.
Right. So, some of you might be thinking right now, don't students actually hate group projects? And we hear a lot of students complain about it, but we think that a big part of this is actually the way group projects are executed in schools normally. So nobody would really like to get stuck in a group with people they don't like and be forced to do a project they don't really care a lot about. So to avoid a situation like this, there are definitely some things to be careful about when assigning group projects. And we think that the first and foremost thing is to give students some degree of flexibility, especially regarding the topic of their project, since if they pick the topic themselves, they're much more likely to actually enjoy it and be excited to work about it. Whereas if they were just told to, do this, do that, it would kind of fall short for the excitement aspect of it. And the other thing to consider is obviously the actual groups that the students are in. So there's both pros and cons to both letting students pick their own groups versus actually assigning groups. So when we let them pick their own groups, it can be very beneficial because they're more likely to pick students that they will actually work well with. But of course, it can also backfire, and they can do a lot more chatting than actually working if they're in groups with their friends. It's all happened. But with assigning groups, it actually runs the risk of creating a really mismatched work dynamic. So it's really up to the discretion of the teacher to decide which case to go with in this specific class and topic. One thing we would like to talk about, though, is that when assigning groups, we think it's important to match students of a similar skill level, because otherwise it can end up with just one or two students dominating the whole group and intimidating others, which really is not an effective way of learning for anyone. So to make sure the projects end up being productive for everyone involved, it's important to make sure that all the students in the group have something to learn from each other or with each other. And of course, just because students are having a little more independence and learning from each other as well, it doesn't mean that the teacher doesn't play a role in what's happening. Actually, we think that the presence of a teacher as a mentor for students is the most important way that peer learning can be beneficial. Otherwise, if there's no teacher, it's just not going to work. So the teacher's role is basically maintaining workflow amongst the students and making sure that all discussions remain productive and useful. Because I think we've all experienced it sometimes. A discussion just ends up getting repetitive and it doesn't really go anywhere. So to avoid getting to that point, teachers should really keep a close eye on things and kind of redirect the conversation if it's necessary or introduce new points for discussion. And they should also be willing to provide guidance and resources to make sure that students don't just get stuck on something and not be able to kind of progress from there. So it's really just about finding the balance between, leaving them to their own devices and telling them every single thing that they have to do. It's just, guiding them in a way.
Outside of the classroom, another way to implement peer learning is through clubs and after school hours. What, you finished? Another way to implement it is through clubs and after-school working hours. Since clubs and after-school working hours doesn't make the student worry about grades and syllabus, it creates an environment where they're at ease, and that's perfect for peer learning since they learn from each other. So if it's possible, we recommend you to open a club next to your lessons, or provide them with an environment where they can work after hours of school in order to learn from each other and specialize in different aspects of a topic. And when they come together in a project, they can learn from each other, such as, while I can teach him how to solder a motor drive, she can teach me how to code, since she specializes in that and I specialize in electronics. So if you have any resources in school to open a club or an environment that can provide students with resources to work outside of classroom and in an environment where they don't have to bother with grades and getting graded and stress, it's nice.
Yeah. Alright, so that was basically our take on peer learning. Basically, we think that it's really awesome and it can be really, really effective when it's implemented correctly, but it's also critical that a teacher really keeps a close eye on things and guides the students throughout the whole process. And do keep in mind that this is just our experience and we saw that it really worked for us, but it may not work for every single student out there, obviously. So it's really just adjusting to the students' needs and kind of seeing how they learn best. Even so, we hope that we've been able to give you a little bit of insight into peer learning and how it can really be an effective way to teach students. And we'd love to hear your thoughts and or questions if you have any. Thank you.
Thank you.
So do you guys have any questions?
Yeah, can I ask you, thank you very much for a wonderful talk. It's great to have your insights on it. I'd like your insights a bit further on whether the people who struggle, have you had them teaching other people? Does it help them to be explaining to others, especially if they've struggled and maybe got over something? Because you lot are all clearly very capable.
Well, for one thing, we think it's important that it doesn't really get to, like, there's not too much of a hierarchy. So, of course, a lot of students excel in different areas, as you said. So, even though I might not be really good at electronics, they all know that, but it definitely helps me to work with somebody who knows it and really learn from them. And we also think that really explaining it to someone else, of course, is a great way to kind of learn about it, since if you can't explain it to someone simply, you probably don't really have a good of a grasp on it as you should. So definitely having discussions about the topics definitely does help, especially with students who are struggling as well.
What's the ideal group size when you work in groups?
It depends on the project.
So like in FRC, like our group is like 80 people, but like only, I don't know, like 20 of them the actual robot. But I think like there isn't actually an ideal group size, but it depends on the situation. So like for a large scale project such as FRC, you might need a group of 20 or 30 people. And for a convention like this, we're just 4 people.
Yeah. And generally in our APCS classes, when they're making like kind of working on robots and stuff, we usually have groups of like 4 or 5 people maximum maybe, since it's not really that much of a popular class at our school, unfortunately. So it's usually not really huge groups, 3 to 4 people.
How many students are there in total studying this in your school?
APCS. So the APCS class this year has around 12 students, I think, but we have a lot more students working outside of class, so in like club hours, because that class is only open to 11th and 12th graders. So we also have 9th and 10th graders, or people from all grades really, coming in and working in our workspace.
So is electronics and computer science the same subject, or is it separate?
So like we don't especially have it like a specific class, like computers, like APCSA. So like most of the work is done in the after school hours and club hours. So like Some days we stay up at school until like 8 p.m. or like sometimes even like till midnight, and we work on projects, and yes, so like not all of the learning is, as we say, done in the classroom, but more working on the projects themselves.
The total number of people really coming into our workspace and learning about computer science is like closer to probably 100, I'd estimate. I'm not really sure. We've never really had like a head count, but it's
That's for the club.
yes, for the club and after school hours, it's like probably around 100 people.
Thanks again for coming here. It's really great to have you. One question I had is, a lot of what you've talked about doesn't sound very computer science specific. Do you find that this peer learning, do you think it works well in other subjects? Do you see opportunities to transfer that, or is it particularly good in this area?
Well, I think that it could potentially work for a lot of subjects, but specifically for computer science, it works well because even when we're just learning in computer science, a lot of it is self-directed. So if we're working on a project, we're trying to code something, we go to Google, we go to Stack Overflow. So really what we do there is already, a lot of it is very independent. So I think that it works better for computer science than it might work for like maths.
Right.
Because it will be hard to kind of try to teach yourself math without a teacher. But for computer science, since there's already so many resources out there on the internet, it's kind of easier to make it a peer-to-peer thing.
However, we do believe that it helps in every aspect.
Yeah.
Thanks. Can you tell me more a bit about your seminars you ran that when you had 250 students from your other schools around the country coming to you? Can you tell us a bit more about that? Because that sounds intriguing. Who organised that and how was it run?
So it's an event that we host every year. So this year is going to be the 5th anniversary. And it's actually a completely student-run event. So we host the workshops, but we also handle all the organization aspects of it. So we meet up with the caterers and we send emails to all the other schools. And it's really just a completely student-run thing. So it used to be a pretty small-scale thing, actually. Up until last year, we only had like 5 or 6 courses maybe per year. And last year, we actually had a big influx of incoming 9th graders as well that wanted to work a lot, and all of them wanted to host workshops. So we went up to 15 courses last year. And again, these are in very different areas. There's design courses and 3D design. There's programming in different languages and electronic stuff too. So yeah, it definitely helps both the students attending. So of course they get a lot out of it. And by the way, the event is completely free. There's like no charge to attend. So it really, I think it opens up a lot of opportunities for people that would otherwise not be able to learn about these things, because a lot of students, a lot of teachers bring their classes to attend this event to learn more about it or just get an introduction. And it actually also helps us, like as I've said, teaching something is basically the most effective way to make sure that you actually know what's going on and you're really got a good grasp on it. So while we're preparing to host these workshops and explain it to other people, we actually improve ourselves as well.
Is it a one-day event, or is it run over?
It's 2 days.
2 days. So you all organise all the accommodation for everyone as well?
Yes.
Yes.
Wow. Organisation. Well done.
Okay. Any more questions? We've got time for one more, I think.
You mentioned Stack Overflow and things like that. Are there other specific resources that you found really good for your team projects?
GitHub.
Yeah. Yeah. Off the top of my head, I don't think I have any other than those. We look a lot at the documentation and stuff, of course.
Do you tend to follow online courses at all, like
Yes.
Udacity or Udemy or anything like that?
Yes.
I took a PCSA from both Harvard and MIT last year, and
Online.
Washington,
Online courses.
Yeah.
and Purdue.
Yeah. So it's really, we do a lot of online courses, especially if it's something that none of us are really familiar with, because it's a great way to get an introduction. So we do a lot of courses on edX and Udacity too, I think. Yeah. It's more of an independent thing. We don't really get them like nobody really goes, oh, we're all going to do this course now, but it's just kind of for our own learning and on our own time. And we do exchange a lot of recommendations for courses, so there's that.
Thank you.
Super.
Okay, well, thank you very much.
Thank
for
you.
your-
Great.